Okay, today's lesson is about multiplying and factoring polynomials. We're going to start off by talking about what we've done before. Earlier, we distributed constants, which is that fancy word for numbers, over polynomials. For example, 5 times the quantity of 3x plus 1 means that we have to distribute the 5 over everything inside. So we know that 5 times 3x is 15x, and 5 times 1 is 5. So that gave us 15x plus 5. Or another example of what we did before, we have negative 3 times 4, which is negative 12. We have negative 3 times negative 5x. Two negatives give me a positive. 3 times 5, and you write our variable. And then negative 3 times 2x squared, we have a negative times the positive, giving us a negative 3 times 2, and write down our variable. So today we're actually going to be distributing monomials over the polynomials, which means we'll have some variables on the outside. So what do we need to remember when we do these? First and foremost, we need to remember to multiply our coefficients. Okay? What are our coefficients? Remember, those are the numbers in front of the variables. So we have a 9, negative 2, and positive 7. So we're still going to distribute negative x. All right, but the coefficient of negative x cubed, our coefficient is actually negative 1. So negative 1 times 9 is negative 9. We multiply the coefficients, and then we're going to add the exponents of our variables. Of course, the variables have to be the same to be able to do that. So if I have x cubed and x to the fourth, how many x's do I have now? I have 3 here, 4 there. Add those together, and you get 7. And then I have negative 1 times negative 2, which is positive 2. X to the third means I have 3 plus 3 x's is 6. And then negative 1 times positive 7 is negative 7. And of course, I have to write my variable, x cubed. So we took negative x cubed and we distributed it over each term inside of our parentheses to get our answer. So let's try another one. We have 5n times the quantity of 3n cubed minus n squared plus 8. We have to distribute everything on the inside is going to get what's on the outside. That's our salt over our chips. So 5 times 3 is 15. We have an n here. We don't have to write it, but there's a 1. You need to think about the fact that there's a 1 there. So if I have 1 here and 3 here, I now have 4. 5 times negative 1 is negative 5. 1n and 2n, 3n, positive 3n. And then 5 times 8 is 40, and I still have an n. So that's my answer. And the key thing we're doing here is the directions say to well, this one says write in a simpler form. You also might see the words simplify. So if you see simplify, then you're going to perform all possible operations to get rid of the parentheses, but you can, so that means we're going to distribute. Okay, now look at the next thing. And what we're doing is we're starting to do this process backwards. But first, we're going to try to figure out what's being distributed. And as we talked in class, that's kind of the same thing as what is that salt? Where is that salt? So what we're doing when we do that process is we're finding the GCF, which in case you don't remember, stands for the greatest common factor. Okay, and to find our greatest common factor, we're going to go through a two-step process. The first one we're going to do is we're going to go look at our coefficients again. Remember, those are the numbers before the variables. Okay, how do we do that? We're going to write down our coefficients that we start off with. I'll do it over here. So I have 5, 25, and 45. Okay, and to find the greatest common factor, we're going to divide. We're going to say what number goes into all three of them. Hopefully you see that's 5. 5 goes into 5 one time. 5 goes into 25 5 times. 5 goes into 45 9 times. Look again. Is there anything that goes into all of those numbers? No, there's not. So that means this right here is my GCF. So I'm going to start off writing 5. After you take care of your coefficients, you have to go look at the variables. And you're looking for what variable is in every term. Remember, the terms are separated by the plus sign or the minus sign. All right, do I have a variable in each one? I do. And so I'm going to have an x. And you write down that variable, but then you're going to write down the smallest exponent of that variable. You have to look in each term, but your answer will be the one with the smallest exponent. So this has x to the third, x to the second, and x. The smallest one is x, so that's going to be my answer. Let's do another one. So we start off with our coefficients. 3. You don't need to worry about the signs. You just need to worry about the numbers, so we don't have to worry about negative. 3, 9, and 12. What number goes into all three of them? The number 3. 3 goes into 3 one time. 3 goes into 9 3 times. 3 goes into 12 4 times. Okay, if you ever get a 1 down here, you know that you're finished because if the highest number that goes into all of them is 1, you have found your GCF. So there's my GCF, 3. So I'll write that down. And then I'm going to look at my variables. They each have an x. That one has a 4, that one has a 2, this one has nothing, which we know is a 1. So my answer is 3x. And that is finding the GCF. So when your directions say, what is the GCF? Then all you're going to, so you're looking for this part in your directions, then that's all the answer that you have to write. It's just one term. Okay? Now we're going to really undo the process that we just started. And when you see that, our directions are going to say factor out the GCF. Okay? And our answer is going to be a little bit different, but the first thing we're going to do is go find that GCF. Now, if you notice, this expression is the same thing that we just did earlier right here. That's the same. It says 5x cubed plus 25x squared plus 4x. We found our GCF was 5x. Okay? So when you find that, you're going to write that in the beginning and you're going to put parentheses. Now, to show you how the rest of it works, I'm going to go ahead and write out our little finding the GCF with the number part. We had a 5 and a 25 and a 45. And then we wrote down 1, 5, and 9. These are the numbers that will appear inside your parentheses. So um, let's go start off again, have our steps so we can look back at them. Before, when we were simplifying, the first thing we did was multiply. Well, the first thing we're going to do now is to divide. So we divided our coefficients, and that's the process that we did right here. The second thing we're going to do, instead of adding, we're actually going to subtract our exponents. So watch how we do this. So I had 5x. My coefficient is 1, which we know we don't have to write, but I do have an x there. I started with 3. I take away 1. What do I have left? 2. I'm going to carry the plus with it. There's my number, so I don't even have to do the work. I started with x squared, or two of them. I take away 1. How many do I have left? I have 1 left. And then 45, I know my number is going to be 9. I have 1x here, 1x there. Take it away. That's all I have left. So I'm done. Okay, so that was an example. Let's do another one. So we start off with, we're going to divide our coefficients. So I'm going to come over to the side and do 9, 15, and 12. And I'm looking for a number that goes into all three of them. So it's the 3 again. 3 goes into 9 3 times. 3 goes into 15 5 times. 3 goes into 12 4 times. I don't have a 1, but there is no number that goes into those, all of those except for the number 1. So this again is my GCF number. So I have a 3, and then I notice that I have an x in every term, and I have the lowest exponent that I have is a 2. So this right here is the first step that we did, which is our GCF. So we write it on the outside, we put our parentheses, and remember these are the numbers that will be on the inside. So I'm going to have 3x, I had 6, I take away 2, I have 4 left. Carry the plus side down. Next number is going to be a 5. I started off with 4, I took away 2, I have 2 left. Last number is 4. I started off with 2, I took away 2, I don't have any left. So I'm done. And the nice thing about this process, you can multiply it back out. 3 times 3 is 9. X squared, x to the fourth is x to the sixth. And you can do that to each term to make sure you have the right answer. So that summarizes our lesson of multiplying and factoring polynomials. You may stop here if you feel good about it, or you may continue, and I'm going to work lots of examples. Okay, now we're going to do lots of examples, and I've decided that I'm going to work in columns so that you get some examples of each type, and if you understand it, you can stop and then go finish the rest by yourself instead of doing all of the same problem. So on the first type, we have simplify each product. Remember, simplify means we want to perform any possible operations. We have multiplication and we have to distribute. So we multiply 7 times 1 is 7. X times x is x squared. 7 times 4, we carry down the same sign, plus 7 times 4 is 28. And we have an x, so we have to have that also. So that gives us 7x squared plus 28. Okay, number 12. We have a negative w squared times the quantity of w minus 15. All right, we're going to distribute. So I have a negative times a positive, giving me a negative. I have w squared and w, which is 2 w's and 1 w. Add those exponents to give me w to the third. Then I have a minus and a minus, or negative times a negative, giving me a positive 15w squared. So that's two more examples of simplifying. Now let's do some GCF. Again, keywords. Find the GCF of the terms of each polynomial. So this is the one where we start off looking at our coefficients. My numbers are 12 and 20. And what number do we know goes into both of those? Let's try 4. 4 goes into 12 3 times. 4 goes into 20 5 times. We didn't get a 1, but we know that 3 and 5 have nothing in common, so this is my GCF right here. So I'm going to have 4, and they do not both have a variable, so the answer is just 4. Okay, look at this. This is a trinomial of the third degree, so it's a cubic trinomial. I'm looking for the GCF, so I'm looking for a number that is common to all of those. And since one of my numbers is 1, I don't have to worry about the numbers. So I do notice that each one has a variable, and we write down the variable. We always take the lowest exponent. I have a 3, I have a 2, and a 1, understood 1, so the answer is just 1. And that's our simplifying. And now we have factoring. Okay, this is the going backwards from what we did on the first type of problem. So we have to find the GCF, writing down 9 and 6. What number goes into both of those? I'm going to go for 3. 3 goes into 9 3 times. 3 goes into 6 2 times. So 3 and 2 have nothing in common. So my GCF is 3. And when we're factoring, we have to write the GCF out, 3. Then I look to my variables. I don't have a variable in each one, so I put parentheses. And remember, these are the coefficients of what's left inside. So I'm going to write 3. I have a variable that I have to keep with it. Carry down my minus, and 2. So that is the factored form of that linear binomial. All right, on to 24. Looking at my numbers, I have 5, 20, and 15. Hopefully you can see that 5 goes into each of those. 5 goes into 5 one time. 5 goes into 20 4 times. 5 goes into 15 3 times. I got a 1, so I know I'm done. So I write down my 5. Then I look to see if there's a variable in each. There's not, so I'm ready to put my parentheses. I have a 1, which means I'm going to write whatever I have left of the variable. So I have k to the third. Since I have no variable outside, my variables will just stay the same. Carry down the sign, plus, I got the 4 right here, plus 4. K squared stays the same. Carry down the sign, 3, and there's no variable. So we are done. All right, let's go back up to the top. 8w, oh, that's not the top. Okay, got to be careful. Simplify each product. Okay, notice over here we started with 7x on the left, and over here we have the 2b on the right. It does not matter. These are multiplication problems. This is an example of our commutative property where the order that we multiply things in does not matter. So we still have to distribute. B times 2b. All right, remember we multiply our coefficients first, so I have a 2, and b times b, I have 1 in each place, so that means I have 2 of them. Carry down my sign. 11 times 2, and carry down my variable. And that's what we get. We're back to having it on the left side. I have my 4x squared, 4x times 2x cubed. Multiply my coefficients. Write down my variable. I have 1 on the outside, 3 on the inside, giving me a total of 4. Go to the next one. 4 times negative 7 is negative 28. X and x squared is x to the third because there's 1 here and 2 here. Carry down my sign. 4 times 1 is 4, and x times x is x squared. All right, down to GCF. All right, we start off looking at our coefficients, 8 and 18. Hopefully we notice that they're both even numbers, so we know 2 goes into both of those. 2 goes into 8 4 times. 2 goes into 18 9 times. So that leaves me 4 and 9 have nothing in common. So I write down my 2, and they both have a variable. So I'm going to write down my variable, and we take the lower exponent. This is a 2, this is a 1, so it's going to be just the 1. Again, write down my numbers. I have a 4, 12, and oops, I started to write that negative sign. We don't need that negative sign. 4, 12, 28. What do they have in common? 4. 4 goes into 4 once. 4 into 12 3 times. 4 into 28 7 times. I got to a 1, so that means I'm finished. My greatest common factor of coefficients is a 4. There's not a variable in every term, so I'm left with just 4. Now look at this problem. When we look at my numbers, my coefficients are 1 and 8. If I have a 1, then we don't have a GCF higher than 1. So then I look to see about my variables, and I have a variable of t in both terms, so I take it out. Started off with 2, took 1 away, I'm left with 1. And then I started off, well, I have my coefficient of 8. Start off with one variable, took 1 away, that means that's all I have left. And the nice thing about these, you can check them. T times t is t squared. T times 8 is 8t. All right, let's factor again. I have 14, 2, and 8. What do we have in common? We have a 2, gives me a 7, a 1, and 4. So I know I'm done because I have a 1. So 2 is the beginning of my greatest common factor. I have an x in every term. Lowest exponent is a 1. And these are my coefficients for my inside. So I have 7 x cubed, take 1 away, leaves me with x squared. I have a 1, x squared, take away an x, gives me an x. I'm dividing, of course. I'm just talking about the exponents when we take away. My next coefficient is 4. I started off with 1x. I took 1 out, so I'm left with just my 4 and no exponents. All right, last set. Back to distributing. Okay, the directions say to simplify. 3m squared times 10 is going to give me 30m squared plus 3m cubed. Keep in mind you can pause this at any time and try to work the problem yourself and then check yourself. Okay? Negative 8y times 7y squared is negative 56y to the fifth. I added 3 plus 2. A negative and a negative give me a positive. 8 times 4, y cubed, and y give me y to the fourth. And negative times a negative is a positive, and 1 times anything is going to be what I started with. Or is that anything, however you want to call it. Okay, back to factoring our GCF. 45b plus 27, so I'm looking at my coefficients, 45 and 27. Start with whatever number you want to, but I kind of want to do an example in case you don't see the largest one. 3 goes into 45 15 times. 3 goes into 27 9 times. You notice they still have something in common. I don't have a 1, but there's another number that goes into both of these, and that is 3 again. 3 goes into 15 5 times. 3 goes into 9 3 times. Now I have two numbers that have nothing in common. So this was a little bit different. So I'm glad we had an example like this. When you do that, however many times you bring a number out like that, that's your GCF. You multiply those things together. So my GCF in this case is 9. They don't both have a variable, so it was just 9 because I got that by multiplying 3 times 3. All right, number 20. I have the numbers 14, 42, and 21. I find it easiest to start with your primes and the smallest one. 2 doesn't go into everything. 2 goes into 14 and 42, but not 21. 3 goes into not 14. 5 doesn't go into any of them. 7 7 goes into 14 twice. 7 goes into 42 6 times, and 7 goes into 21 3 times. These two are primes, so they have nothing else in common. We have our 7. Each of them has a variable of z, and the smallest exponent is a 2. And now we're going to do some factoring. So we have 14, 35, 28. We factor each of those. 7 goes into 14 2 times, into 35 5 times, into 28 4 times. Now these two have something in common, but the 5 doesn't. Got to have it in all of them. So I'm going to have a 7. They do not all have a variable, so I'm going to write what's left. There's my number 2. Didn't take out a variable, so my variables will all stay the same. My signs stay the same because I didn't factor out any kind of negative. So there's 23. And last but not least, we have a 1, so I don't have to worry about any numbers coming out, but they do all have a g. And the lowest exponent of g is a 1, so I'm going to take 1 away from every exponent. G to the third plus 24g squared plus 12g plus 4. And there you have it, all the problems from our day after our instruction.